if you have your Julia, make sure that it's open so we can kind of work together. Before we start, Julia, I'm going to explain to you what is Newton's method is, okay? That's your numerical method that you solve a complex equations. That's something that you cannot do by hand or by, like for example, your calculator can give you answer for a lot of equations. That's something that we cannot do algebraically. Like, you know, there's some equations you cannot find solutions. If say, like say polynomial of the degree of a 5, say x to the 5th plus like 3x to the 4th plus like 2x squared plus 7x plus 8. Okay, this complex polynomial, you don't know how to solve it because you cannot use a quadratic equation because we don't have equation to solve 5th degree polynomial. Okay, but somehow your calculator can give you answer. Okay, they can give you answer to your complex equation. The reason that you can do it because they're using a numerical method. So one of the methods is very popular, very well known, is Newton's method. Okay, the Newton's method to figure out the solution of your complex equation. So a lot of equations, okay, a lot of functions, okay, you cannot solve algebraically. That's almost impossible to solve it. Almost every one of them is not solvable by hand. So usually you do have to use a numerical way to do it. So one of the popular one or most simple one that we do is a Newton's method. Well, later on you can do bisecting method, but there's a Longo-Kutta method. There's a different method you can do. But for us, we're just gonna do the Newton's method. That is like just fine to it's a very good method, numerical method to figure out the solution of the equation. All right. So let me explain to you what it is. So I want you guys to look at this. This is a definition I'm going to look at from Wikipedia because I want you to look at the graphs and what's going on. So when you look at the Newton's method, okay, the Newton's method is a what? A numerical is known as there's another name, doesn't matter. Anyway, a Newton's method is the most basic version starts with a single variable function f, defined of a real variable x, the function derivative of f prime, an initial guess of x0, and for root. And so we need to have, okay, to find, we need a real variable x. We're trying to figure out the real variable defined for a real variable x, a function, derivative, and I need to have an initial value of that function. All right, satisfy sufficient assumption to the initial guess at close. So the Newton's method, this is your formula. Okay, x, so which means your solution. I'm trying to approximate your. I am trying to start with a guess of what the solution would be, okay? And then using the initial guess, I'm going to approximate better and better to find the real solution. Okay, that's what it is, but the formula is that. Let me erase this. Okay, now, so I want you to look at this. So this is a great thing. So what it means, you have, say, function. The blue graph, okay, this blue graph right here. This blue graph right here is your function. Some function, all right? And the solution is right here. All right, but I don't know that solution. I want to find that solution. Okay, this is my solution. All right, but I don't know the solution. So what I do, I was starting with a very first initial one. So let's go back here so we can, okay, starting with the now. You're gonna start with the very first one. I'm gonna guess my solution to be here, which that is not solution, right? So you draw a tangent line. Okay, so now become your second guess. All right, and now I'm going to do another calculation. I'm going to draw myself here, over there, and then I'm going to draw my tangent line. Okay, so this red one. Okay, what I can do, actually, I can draw a new one. Let me just draw myself I'm gonna stop this. So I want you guys to, let me explain. So Newton's method means, let me share with this screen. Okay, Newton's method, three things. We need x naught, which means you're starting with a sum point of x, okay, starting point. This is a guess. You just guess this number. All right, you just start with it. Like you need to do educated guess. In other words, okay, have a good educated guess. And we need a, of course, that will give me a function. It's a given function. To use Newton's method, you gotta have this, okay? And then I gotta have f prime, which you're gonna find it, okay, right? You're gonna find f prime from f, okay? Then this is what they do. They're saying, okay, if I have these three things, I can find a solution. Even your equation is very complex, that you cannot solve this equation algebraically, you can solve it. Like a calculator can solve the answer, so you're gonna do the same thing. In other words, you're creating a program of the complex problem using a Newton's method to figure out the solution. That's what it means. Okay, is everybody with me? Okay. And then, so Newton's method has a formula. The formula says, okay, if I have these three things, yes, if I do more and more iterations, do the repeat competitions again and again, then I can find the solution. So they were saying the solution, well, I would just say x1. This really means getting solution, okay? Getting solution is equal to x naught minus f of x naught, everything divided by f prime of x naught. Okay, that is the Newton's method, approximation. You're gonna iterate again and again and again until you get solution close enough that you don't mind having that x to be your solution. All right, so let's understand what this means. So for example, say I have a graph. Say I'm going to have my my graph looks like this. It's a sum function. Okay. Then I'm going to say, okay. By the way, you need to in order to have a solution, you will have there's some negative y values and some positive y values. Okay, so in other words, you gotta have a sum, which is right here, negative y values. And over here is what? A positive y values. If you don't have a sign difference between x, two y values, between your two x's that you choose, that means you may not have a solution. So Newton's method does not work if your graph looks like this, for example, here. Okay, if your graph looks like that, okay, in that case, Newton's method does not work because this equation, okay, this is x squared was x squared plus a 4. Okay, this equation does not go through the x-axis, so there's no solution. Okay, this kind of thing, you only have imaginary number as your solution. Okay, so Newton's method only works. So in this case, okay, in this case, Newton's method going to fail because you don't have an y value that is negative and there's a positive, because the y value has to have a sign difference. The sign has to be different to have a solution that the equation crosses x-axis. All right, for example, this one solution is right here. This is your solution. Some x value, that's your solution. But we don't know. That's the what we're trying to figure out. Okay, say, I don't know how to figure this one out because my equation is very complex. I cannot solve it algebraically. So a better way to solve is numerically. So that's what we're gonna do. Numerically, we're gonna figure this one out. So the Newton's method says, okay, if you have the condition that met, which means y has a negative value and y has a positive value, there's a sign differences between y values and certain x, okay, then yes, I can use Newton's method. Like this graph in the yellow, the function, the yellow graph, that you can use Newton's method because you see a one of them right here. You have a as you can see, you have a y value differences. Right here. Right here is a negative values. Of this way is what? Positive values. So you have to have that condition met. Okay, Newton's method does not work if it looks like this. It's all positive y values. Okay, there's no negative y values. So you know that this equation does not go through the x-axis. The equation, the graph has to pass x-axis to have a solution. Okay, as you can see, the x-axis is over here, and your graph is way above x-axis. In this case, you do not have a solution. Newton's method does not gonna work, and it's gonna say fail because there's no solution starting point. Okay, so now let's look at the case that Newton's method worked. So the first thing what you do, you just choose a number, good educated number that'll be close to it. So I'm gonna call it right here. I'm gonna call this to be my first number that I choose. Okay, I'm guessing this number. I'm gonna give you that number to start with. Okay, well, you can just choose some number to start with. Then what do you do after that? You're gonna go up. Okay, draw yourself to a dot, that y value. Okay, then you're gonna draw the tangent line to this. This is y prime of x now. Okay, you draw the tangent line. So when you draw the tangent line, look at that, where's tangent line crosses x-axis? Right here. All right, so now that is my second guess. My first guess was x0. Now second one, this is x1 will be what? Your second iteration. All right, now I'm gonna say, okay, as you can clearly see, the second iteration didn't give you correct answer. So this is your x1. Okay, now what I do, since x1 is not close to real solution, so I'm gonna do another thing. I'm gonna draw myself another tangent line. Okay, this time, your second one, okay, the x2 is much closer to real solution. It's a third iteration, which is what? Getting closer to the true solution. Right? But look at the red dot and blue dot. They're not very close. They're very close. So I'm gonna say, okay, let's keep trying. So now this is my x2. So, but it's not really, really close. I want it to be very, very close, which I'm gonna also give you tolerance. I'm gonna say, okay, my tolerance that I will take as my answer is 0.005. So as long as my guess and my real solution is the difference is 0.0005, I will take it. Okay, that's what it means. So I'm gonna say, okay, I just want to do one more iteration because it looks like if I do one more iteration, the solution will be very, very close. So what I do, I go up, draw a separate line, and I'm going to draw a tangent line. Look at that. Doesn't that almost go through the real solution? So my third iteration, the fourth iteration, is almost same as the real solution. So that is a concept of Newton's method. Are you following me, class? All right, I'd like to know, does anybody have questions about this concept of a Newton's method? Okay, so write it down if you have a question, or show me your face so I know you have a question. Is everybody with me? Yes or no? Okay. So is everybody with me? Are you following me? Yes or no? It's chapter 3. It's a chapter 3, lesson 7. It's a Newton's method. We're still in the chapter 3. Remember, I didn't give you Newton's method as a part of your exam in chapter 3. So I'm finishing up the chapter 3. So this becomes your semester project. So you need to pay attention. So this will be your other grade. Remember, semester project is 10% of your grade. Because I want you to write a function in Julia code to do this work. Not manually, okay? Because this is made to do numerically, which means if you're gonna do numerically, that means you need to write a function program to do it. That's what computer does the best. They iterate very, very fast. So pay attention. So you need to understand the concept. The concept is this. Okay, so did everybody understand my picture? Because I'm gonna move on and practice. Let's practice the easy problem so we know for sure. Let's just starting with the example. Okay, I'm just gonna do the example one that's easy to do. Say if I choose f of x equal to x squared minus 3x plus 4. All right, so if you graph this, okay, by the way, I'm giving you easy problems so you can understand what I am doing to understand the concept. So problems that you would do for your project, I would probably give you harder problems, more complex equations, and you need to do that using your program to solve it. But I'm gonna use easy function to demonstrate what the Newton's method means, okay? So looking at this, the graph looks like what? So you go through 1 and -4. Okay. I'm just drawing a function graph for now. So we are solving equation in numerical way, not algebraic way. But we know this answer should be x minus 1. Okay, so this must be 5 then. Has to be 5. How will we use that? Okay, so this is my thing. So looking at that, I know my solution should be, I already know my solution, but let's do this numerically and see whether we can get the same solution. Can we arrive the same conclusion? Okay, numerically, I want to see whether that's correct also. So I know for this, x is equal to 1, x equal to 4, that is a true solution. We will see whether we can get a similar solution using Newton's method. Okay, we know the true solution, which is 1 and positive 4, but we're going to see whether we can get this similar solution using Newton's method. If it does, it'll be like numerically I'm proving, yes, I can use Newton's method to figure out the solution, even it's a complex problem. All right, so I know this equation will looks like 1, it will go through 1 and 4. So the graph will go through 1 and 4. So I have 2 solutions, right here and here. But right now, I'm just going to concentrate on the first one, concentrate on a, say 4. Okay, I'm going to concentrate on the 4 right here. So I'm going to starting with my number to be, my starting number to be, say 3.5. That's what I want to choose. I want to choose that number to be my x naught. 3.5. So I chose x naught to be 3.5. Looking at my graph, 3.5 would be a good number to choose. So what I do, I'm going to move over here and draw myself a tangent line. Okay. So this is f prime of x naught. Okay, so now, so we know, so to do the Newton's method, I gotta choose x naught, I gotta find f prime, I gotta have f. So I already have f right here. So now I gotta find f prime, which is equal to 2x minus 5. All right, now let's use the Newton's method. So Newton's method says ux is equal to x naught minus f of x naught, everything divided by f x naught, f prime of x naught. That's first iteration. Okay, the first iteration is there. So let's plug it in there. My first iteration will be x naught is 3.5. I am doing this manually, and then we're gonna use this one, we're gonna write a program to do it. Okay, I'm just doing a simple problem with you, so you know what to do. So f of 3.5, everything divided by f prime of 3.5. So what is, let's figure out what is f prime. I guess we can just continue the same color. That means 3.5 minus, what is f of 3.5? So we have this. Okay, so let's make a note. F of 3.5 is the same as, so 3.5 minus 1, 3.5 minus 4, which is 2.5 times 0.5 negative, right? So what do you get? If you want, you can put in your calculator, but I'm just doing it. So 2.5 is the same as what? 5.2 times 1/2 of negative, so it'll be negative 5 over 4, which is same as negative 1.25. So we just got that part. See how tedious that is? If you do this by hand, it takes you for a long, long time because you gotta figure this one by hand. So I'm gonna move into calculator in a minute, into my Julia in a minute. So I have, this is equal to 3.5 minus, which is negative 1.25, everything over. Now I gotta find f prime of 3.5, f prime, which is f prime is right here. So f prime of 3.5 is equal to 2 times 7 over 2 minus 5, which is 7 minus 14 over 2 minus 10 over 2, which is 4 over 2, which is this case is 2, which good thing it's easy now. All right, still it's a lot of work. So you gotta you have this and you get a 3.5 plus 1.25, 5 over 4 over 2, 3.5 plus 5 over 8. So you will have a sum number, which is what? Let's do in a calculator. Let's do that in a Julia. So it'll be much, much easier. So remember your problem. Okay, the problem is x squared minus 5x plus 4. That's the problem. Okay, so I'm gonna share my screen. Okay, let's do Julia now. So does everybody open up your Julia? Okay, so this is the Julia that I'm doing. Okay, is everybody watching my Julia? Can you see my Julia right now? Yes or no?
Yeah, I can.
For some reason, I'm not seeing it in my screen. Do you see it? Okay, yes, I do see it now. Okay, great. All right, so I do see Julia. So now I'm gonna write down the things that we've been writing down. So we decide f to be what? Because I don't want to do that by hand, it's taking forever. So x is equal to the one that we chose was x to the square minus what? 4 times x and plus 5. That's what we chose. Okay. Does everybody have the same thing that I have? Now, we decide, and then we know what f prime is, right? So I'm going to call it f prime of x equal to 2 times x minus 4. Did I write down my problem right? Hold on. What was my problem was? This is a 4. And this is 5. Wasn't it the problem that we had? Okay. That's the problem they should have. Okay, the f of x is equal to x squared minus 5x plus 4. That is the problem that we have. Okay. And then I'm going to say, okay, let's be using plots. So we can draw a graph. Because remember, you need to estimate what x not to choose. Okay, which first initial value to choose? Somebody asked me a question. Okay, what was the question you're asking me? Okay, so I'm just using plots. Are you with me right now? Okay, I hope you guys also doing this with you because I told you to make sure that you have your Julia set up. Remember we set up the Julia very, very beginning of the semester? So you need to have you open up your Julia so you can follow me. And then this is recording right now. Our lesson is recording, and then my student work are going to upload it so you can watch it later. But you do have to have Julia set up in your computer. Otherwise, you cannot do this work. If you do need to calculate, if you need to borrow a computer, let me know. So maybe I can let you guys lend my computer tomorrow. Okay, I can meet you guys at school. So you can borrow mine, so you can work on this over the weekends. You can turn it into me by next Tuesday. So this project is due by next Tuesday. So you need to make sure you have everything you need. So let me see what's going on with mine. I'm gonna close this one. I'm gonna open it. Let me start from the beginning. So when you see it, this is what you're gonna see. When you open up your Julia console, this is what you're supposed to see. Okay, and then I'm gonna give myself a function. The practice problem that I'm gonna do is x to the square minus 5 times x plus 4 is the function that I'm gonna use, right? But before I do anything, I like to know my graph. What is my graph looks like? So I'm gonna say I need to use a plot function. The plot function is a built-in Julia function. Okay? Julia has a plot function that you can just use. You don't have to write it. You don't have to write a program for it. Julia already has a function called plot. So you're just gonna make me use it. So right now I say using plot. So I'm waiting on this to load it. So it's taking some time. So I'm gonna wait. Meanwhile, does anybody have a question that you wanna ask me? And then also you need to send me a text message or email. Well, text message is probably good because I look at it all the time. So look through the GroupMe and tell me if you need to borrow a computer. So that means I will go to school tomorrow so I can lend you a computer. All right, so using plot is already uploaded now. So I can start using plot, okay? So I'm gonna say, okay, now I'm gonna give my x to evaluate. So I'm gonna say, I'm gonna use my x to be between, say, 0 to, say, a 0 to 5. I'm gonna use 5 numbers, 0 to 5. Okay, now I'm gonna plot x versus f. So I want to see my graph. So I'm graphing x from 0 to 5. That's what I wrote. X equal to 0, column 5 means I want my x to be 0, 1, 2, 3, 4, 5. That's what that means. Okay, so I'm waiting. So right now, Julia is plotting. So I'm waiting for Julia to finish plotting so I can show you what it looks like. We already know what the graph looks like, by the way, but this is what you usually do. And I am waiting my plot to show up. Let me see where's my plot. Okay, so maybe because I'm using a Zoom along with this, it's not showing up. But you know what the graph looks like, okay? So assume that it show up, because it should show up on your screen, by the way, okay? It was showing up because I was doing it previously before I have this class, because I want to make sure that everything is working properly. So I did see it when I didn't use the Zoom, but I don't know why it's not showing in the Zoom, but that's fine. But you know how the graph looks like. So now next thing is you gotta choose your initial value. Okay, you gotta choose initial value. So in our case, we chose 3.5. So give this number, you chose that number. Now gotta find f prime. F prime is what? So look at the graph right here. That's your functions. F prime would be 2 times x minus 5. It's your f prime. All right. Now, so you're gonna say my first iteration. I'm gonna just call it new, okay? Or just say 1. First iteration was, what do? X naught minus f of x naught divided by f sine of x naught. So I got new number. It says your new number, okay, the first iteration, okay, the first iteration is now 4.125. Remember the solution is supposed to be 1 and 4. So we are looking for a solution 4 right now. Okay, I don't care about the 1 right now. That one I will do later. So 4 is a solution. So 4.125 is very close to 4, but it is not close. I need to set myself a tolerance, by the way. Say I would take my iteration, my numerical solution, as long as this is close enough. My close enough may be 0.00005. Okay, I'll look at it in a minute. So I'm going to set myself tolerance to be 0.0005, which means the first iteration and the second iteration, the difference is less than 0.0005, I will take it. So I set my tolerance. So now I'm going to say, okay, let's see x. We already know, but say x1 minus, I'm going to do the absolute value of x1 minus x0. I want to know what that number is. Okay, the difference is 0.625. All right, so I said, well, that is not close enough because I want that number to be less than 0.0005. So the total, so the difference is definitely too big. So I'm going to say, okay, then I'm going to do another iteration. So my second iteration is now I'm doing a x1 instead of x0s, okay? Okay, now my new answer gives me my new iteration, my new solution. Of course, approximation to new solution is now 4.004. Okay, so let's do the absolute value of again. Absolute value of x of 2 minus x of 1. What is that equal to? Okay, the difference is still more than my tolerance. Remember, my tolerance is supposed to be 0.0005. Then I will stop. So I need to do another iteration. So I'm going to say, okay, I'm going to do my third iteration, which is this case, I'm going to plug in 2 as my second one, right? F of x2, f prime of x2. And I'm going to do it. Okay, so my x to the third, which is my third iteration. Okay, my third iteration is 4.0000. So I'm going to add absolute value of x to the third minus x to the second. What is that equal to? Okay, it's getting very close. The difference is 0.004. What is my tolerance that I want to use? I want my tolerance to be 0.005. So this number is still too big. The difference between second iteration to the third iteration is still too big. I would say I want to do one more iteration. Okay, let's just see what those do. So I'm going to do, okay, I'm going to do next iteration, x to the fourth. Going to be x to the third minus f of x to the third divided by f prime of x to the third. Okay, I know for sure this is good enough. So let's do it. Absolute value of x to the 4 minus x to the 3. Yes. Now I can stop because the difference between fourth iteration to the third iteration is 0.000007, which is less than my tolerance. So I can stop now. So my solution is, in other words, my solution is what? X equal to, I can just say what? What's the number that I chose? Almost 4 then. In other words, 4.00000, so which is 4. The solution is 4. You got it. So you're done. All right, that is a Newton's method. So your project is I did this manually one at a time. I want you to write a program in Julia to do this automatically, not just doing one by one, but you need to make automatically do it. So I'm going to go back to my notebook so I can explain to you. Okay, does everybody understand what I just did? Okay, show me if you have questions, you need to ask me now because this is your project. Your project is, I did this manually one at a time, one iteration at a time. I didn't write a program, I just did it one at a time. Now I want you to write a program called Newton's method that you plug it in 4 different things. So this is what I'm gonna do, I'll show you. Okay, so this is what I want you to do, your project. Semester project. Write a Julia function using Newton's method to solve a given problems. I didn't give you all the problems yet, but I want you to try with this easy one that you already know. So example, the one that we choose is this. All right, using that, that's the problem that we chose. Now, I will write it down, all the functions that I want you to find. For now, this is just a practice problem. This is the practice example equation that I want you to find using a Julia. So on your function, this is what you have to do. Excuse me. So example, Julia function, you need to look into it, okay? Google the Julia. So this is your project, means you need to do some hands-on practice. And you need to go see your PRTL leaders. They have done Julia before during the summer, so they know. So I recommend you work with your PRTL leaders and reach out to them, okay? I hire them to help you. So you need to make sure you work with them so you can do your project right. So you need to start in with the Julia function. If this is in console, or you can use editors, whichever. You can use editor or you can use console, whichever you want to do. So you need to start with this is your start with. You're going to say function. So you're going to say Newton's method. Okay, so Newton's method is a name of your function. And then this Newton's method takes 4 things. All right. And then you're going to write down what is your x1 is. So I'm going to call it new. And then you need to write down the conditions right here. Okay, you need to write down condition. How long you gonna do your iterations? Right, you wanna do your iteration as long as what? You're gonna say if absolute value of x new minus x0 is what, less than tolerance, and do the calculation that we done. So this is like a frame of your program that you need to write. Okay, so function that you gotta give, you need to give x naught, f, and f prime, and tolerance. You need to give that to your function, and then your function going to do the iteration again and again. All right, so we did Newton's method manually using a Julia one by one. But that is a stupid way to do, because you can write a program, so you can just plug it in, initial number, give a function, function prime, and tolerance. Your Newton's method is supposed to do by itself and then spit out the answer. Okay, so that's what I want you to do. So tomorrow I will go over more, and you can ask me questions you need to. And if you do not have a computer, whether you cannot download Julia because of whatever the reason, you need to work with your PRT leaders, make sure you take care of that problem. Because your project is due next week. I haven't set the date yet, because I don't know what kind of problems you may have right now and tomorrow. And I will set the date. But your project is writing a Newton's method in Julia, and you're gonna do automatically spit out the answers. Whatever the equation that I give you, you will spit out the answer, say, this is the answer. Okay, that's what you have to do. Yes, this will be on the YouTube. So as soon as we finish with our lesson, I will forward this to my student worker, and she's going to edit it and upload it to YouTube. So if you are subscribing to my YouTube channel, when she put it up, you should get a notification. Because so she does it for me automatically. All right. Okay, anybody have any questions so far? Okay, so if you don't have any questions, so this is your project. Okay, Newton's method, writing a Newton's method in Julia to do your any kind of homework, any kind of equations that I give, you need to give me a solution. Okay, so this is your project. All right, if you don't have any questions, I will probably let you go. Before you go, please say I am here, so I know who is here today. All right, you guys have a good day, and I will finish grading your exam today, so you will see your grade by this afternoon, because I'm still grading your paper. It's quite a few stuff to grade. There's like 13 steps, so it's taking me a while to grade, because I don't let anybody grade your exams. I grade your exam because I want to know exactly what's going on. So it takes me a little more time. All right, you guys, have a wonderful day. And your project is writing a Newton's method in Julia. And you will get to give me a solution of any equations that I give. All right? All right. So do need more research on Julia, and do need more research on Newton's method, and ask me a question tomorrow. All right? All right, I will see you tomorrow. If you need a computer, you need to let me know. So I need to go to school tomorrow to accommodate you.